Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to wrap up AC power analysis topic. In this AC power, it has lots of powers. So we need to familiar with the name, the abbreviation, and also unit. Okay, let's start for the first power, instantaneous power. And the abbreviation is small letter of PT and unit is watt. As we know that the basic formula for power is P equals to IV. So instead to this PT, so PT will be equals to instantaneous voltage times instantaneous current. Okay, we are now in AC condition. So this time domain relates with three elements of amplitude, omega, and also angle. So this instantaneous power will be Vm Im cos omega t plus theta v cos omega t plus theta I. Okay, this instantaneous power changes with times and it's therefore difficult to measure. So we need to apply trigonometric identity. So after we apply the trigonometric identity, this instantaneous power will be separated into two parts. The first part is average power. Second part is sinusoid. Okay, this sinusoid is time dependent and this average power is constant and also convenient to measure. So we focus to this average or constant power for analysis. Okay, let's take a look at average power. This average power is denoted by capital of P and the unit is watt. Okay, also known as constant or real power. And this P equals to half Vm cos theta V minus theta I. Okay, this expression comes from the first part of instantaneous power after applying trigo. Okay, in this average power, the value is in terms of peak value, Vm Im. Okay, for AC, it has two values in terms of peak and also RMS. For AC, the effective value is RMS value. So we need to change this peak value to RMS using the formula of Vm set to Vrms. So instead in this Vm and also Im equals to set to Irms. So average power in RMS is Vrms Irms cos theta V minus theta I. Okay, from average power in terms of RMS, it has two elements. The first one is apparent power, and the second one here is power factor. Okay, this name is apparent, denoted by S, and the unit is VA. Okay, for power factor, the abbreviation is PF and it's unitless. Okay, from this we know that S apparent power is the magnitude of average power, Vrms RMS, and this power factor is simply can be written as cos theta. Okay, let's go to the last power. It is complex power, denoted by S, unit is VA. Since it is also S, so I use this bar to distinguish between apparent power and complex power. This complex power, the formula is Vrms, I use bar, Irms conjugate. Okay, this Vrms is equals to VRMS angle. Also, this one is IRMS and angle, theta I, and this theta V. Okay, for this conjugate means that the inverse from this positive theta I. Let's say the given IRMS theta I is negative, so here when you conjugate it must be positive. You insert to this, complex power will be VRMS, IRMS, and the total of the angle will be theta V plus theta I. As you can see here, this is the magnitude of complex power, and this is the angle of complex power. So this form is polar form. If you still remember, VRMS and IRMS is apparent power, and this theta, you can get power factor because power factor is cos theta. So now you know in polar form, you have the complex power equals to apparent power and theta. So if you have polar form, you have the rectangular form. So in rectangular form, you have another powers of P plus dq. So this P is average power or real power or constant power. So now what is Q? This Q is reactive power. The unit is VAR. Okay, let's conclude about complex power. The formula is VRMS RMS conjugate and the unit is VA. Okay, for complex power, it summarizes all the powers. In polar form, you have the apparent power and theta. In rectangular form, you have the average power and also reactive power. Okay, for conservation of AC power, it relates to this complex power. So if you want to get this complex power for this source, so it will equals to the respective sum of individual load. So if you have 3 loads, so total complex power will be equals to complex power 1 plus complex power 2 complex power 3. This is not the Z. If you do like this, it's wrong. This is not the conservation of AC power. So don't write like this, Z2 plus Z3. This is not the conservation of AC power. Okay, for this individual loads, it has its own type of load, either inductive or capacitive. For inductive, it is positive. Positive is here and also here positive. For capacitive, it is negative. Negative here and negative here. Okay, if you want to get this total complex power, you just need to sum up all this complex power. So now, how to get this complex power for each load? We can use this power triangle to get all the elements. So here is the theta, the power of P, average power. Here is Q, reactive power, and S, apparent power. You can get all this by this sine cos tangent. Sine equals to Q over S, cos is V over S, and tangent is Q over P. Okay, the last subtopic is power factor correction. So in order to get this, you must get this C. C is QC over omega VRMS squared. So where is QC? For power factor correction, it has the new power factor. The new power factor relates with this theta nu. So let's say here is theta nu. So here is Q nu. So here is Q total got from previous total complex power. So you can see here the QC is here equals to QT minus Q nu. And then you insert to this QT minus Q nu over omega is 2 pi F VRMS squared. Okay, that's all for this chapter.